Welcome to the Introduction to Engineering module. All the announcements pertaining to this module will be posted in Blackboard. You are advised to access Blackboard regularly for any notifications on assignments and pre-work activities. I hope you will enjoy the sessions. All the best. As a student engineer, you are part of the engineering profession. In this course, you will develop your identity as a modern engineer who will collaboratively contribute to sustainable and equitable communities. This course will broadly introduce the engineering profession and highlight the socio-technical and interdisciplinary nature of engineering. The themes of the course will enable students to distinguish and practice professional conduct, communicate and interact in a style appropriate to academic and professional contexts, including oral, written, and graphical styles, explain the engineering method from problem formulation through the complete life cycle, generate and assess ideas and solution alternatives for engineering problem solving, critically evaluate proposed engineering solutions in terms of sustainability, economic, environmental and social considerations, and apply basic project management strategies and processes. These themes will be explored through a variety of team and project-based learning activities. After this session you will be able to distinguish and practice professional conduct, communicate and interact in a style appropriate for academic and professional contexts, explain the engineering method from problem formulation through the complete life cycle, generate and assess ideas and solution alternatives, critically evaluate proposed engineering solutions from safety, sustainability, economic, environmental and social perspectives. Engineering services means any service or creative work, the adequate performance of which requires engineering education, training and experience in the application of special knowledge of the mathematical, physical and engineering sciences to such services or creative work as consultation, investigation, evaluation, planning and design of engineering works and systems, engineering studies and the review of construction for the purpose of assuring substantial compliance with drawings and specifications, any of which embrace such services or work, either public or private, in connection with any utilities, structures, buildings, machines, equipment, processes, work systems, projects and industrial or consumer products or equipment of a mechanical, electrical, hydraulic, chemical, pneumatic or thermal nature, insofar as they involve safeguarding life, health or property, and including such other professional services as may be necessary to the planning, progress and completion of any engineering services. Such practice includes the performance of architectural work incidental to the practice of engineering. Engineering services does not include responsibility for the superintendence of construction, site conditions, operations, equipment, personnel or the maintenance of safety in the workplace. Engineering plays a crucial part in every product, every gadget, every system you use in your daily life. Bridges, cars, phones, computers, aircraft, all are designed and produced by engineers. Most people aren't familiar with the work engineers do, because if it's working, you don't notice it. The smooth running of everything from computer systems to traffic lights is all down to engineers. Engineers directly contribute to the well-being of society, and the individuals that make up that society. Engineering also boosts the economy. Engineers work primarily in innovation, either designing a brand new product or improving an existing one. These engineering innovations go on to make our lives easier, more comfortable, or productive. Creative solutions to everyday problems are often at the heart of engineering. Professional engineers have a significant role to play in sustainability. The goal of sustainable development is to enable all people throughout the world to satisfy their basic needs and enjoy a better quality of life, without compromising quality of life for future generations. Population statistics are important parameters that engineers and scientists use to determine the development of open space areas, such as city planning, transportation development, water supply needs for communities and much more. Environmental engineers have begun to evolve from those who characterize, manage, and remediate existing environmental problems to those who develop new knowledge, design innovative technologies and strategies, and implement solutions that prevent environmental problems. Unsustainable development of product manufacture can result from an action that, while based on trying to act sustainably in a local context, creates more severe development problems or social and environmental effects in a broader context, either immediately or in the future. The 2030 Agenda for Sustainable Development, adopted by all United Nations member states in 2015, provides a shared blueprint for peace and prosperity for people and the planet, now and into the future. At its heart are the 17 Sustainable Development Goals, SDGs, which are an urgent call for action by all countries, developed and developing, in a global partnership. They recognize that ending poverty and other deprivations must go hand in hand with strategies that improve health and education, reduce inequality, and spur economic growth, all while tackling climate change and working to preserve our oceans and forests. Engineers are problem solvers. For your laptop to work faster, an electrical engineer must find out how to redesign existing electrical components. Once the concept is constructed, manufacturing engineers must discover how to produce the new components on a large scale for the consumer market. These new iterations of products and procedures require engineers to solve problems and work through possible solutions. If engineers are to solve challenging technical problems, they should be imaginative and optimistic. It is this attitude that can enable them to be successful. Engineers should be practical and resourceful. They need to rely on concepts and know when to refer to books and engineering guides to solve a problem. Their practical knowledge should come handy when needed. A researcher brainstorms ideas and experiments to explore its potential, whereas an engineer develops a practical solution under time and budget constraints and implements it in a real-world environment. Teamwork among engineers is almost always required to complete a job, as most jobs require several engineers to complete. A carton of milk might require several engineers to design the package, test its performance and then produce the end product. Something more complex such as an engine may need hundreds of engineers during development. An engineer should be comfortable working in teams and communicating effectively, negotiating, creating relationships with colleagues, giving feedback and motivating colleagues. Innovative products are the result of strategic and planned thinking, which is an important characteristic of engineers. This attribute clearly identifies a specific aim to solve the problem, the ability to tap into collective knowledge, link unrelated concepts to construct new thoughts and experiment to create technical leaps forward. Engineering contains a large number of job opportunities and specialties. Here a selected list of specialties below is shown here. With each specialty, the definition and nature of the work, The specialties employment trends, possibly career advancement opportunities, are provided. A career in engineering is interesting and fun. It involves a lifetime of continuous learning to adapt to changes in society and the natural world. It often involves working in multidisciplinary, multicultural, multi-site teams. The world will always need engineers, but some specialized fields are growing faster than others. As the population ages, environmental policy changes, and automation takes over more and more aspects of manufacturing, the world needs people out there to design, develop, test, and implement new strategies for meeting these challenges. Here are the fastest growing, most in-demand jobs predicted for 2020. Automation and robotics engineer, alternative energy engineer, civil engineer, environmental engineer, biomedical engineer, and systems software engineer. The variety of engineering jobs available can seem daunting at times. Automation and robotics, alternative energy, civil engineering, environmental engineering, the biomedical field, and software engineering are all rapidly growing in response to a changing world. These positions won't just offer a good salary, they also offer a chance to develop the innovations that make that world a better place. An impressive 87% of professional engineers report being satisfied to very satisfied with their job. But that's only one reason to choose a career path in engineering. There are many considerations when choosing a focus, but pay is certainly a key factor in planning for your future. In terms of median pay and growth potential, these are the 10 highest paying engineering jobs to consider. The rise of big data has provided significant business opportunities, but complex data sets have no meaning if they're not structured in a comprehensible manner. Enter the big data engineer, tasked with creating the hardware and system architecture that enables others to interpret and utilize data. With a median annual salary of $155,500, big data means big opportunities for engineers. Petroleum engineers develop methods for extracting petroleum and natural gas from the ground, and then use those materials to create energy efficiently and cleanly. With a median salary of $132,280, petroleum engineer is one of the highest paying engineering jobs of 2019. The field is also projected to grow much faster than the average career over the next 5 to 10 years. With a median pay of $115,120, this highly technical field involves designing and developing computer systems and components such as processors, circuit boards and memory devices. Computer hardware engineering is an excellent field for analytical problem solvers with an interest in mathematics or physics. This is one career where you get to say actually, it is rocket science. Aerospace engineers design and build aircraft, spacecraft, missiles and satellites. Design skills are a must, as well as sharp analytical skills and problem sensitivity. Median pay in 2017 was reported at $113,030. Nuclear engineers research, design and develop the tools and instruments needed to utilize nuclear energy. They're responsible for safely directing the operations of nuclear energy facilities and must be comfortable with a high degree of complexity. In 2017, median pay was reported at $105,810, landing nuclear engineers in the top 5 highest-paying engineering jobs. Systems engineers manage the technical infrastructure of a company, maintaining all of the hardware and software required to keep the business moving forward. If you have strong communication skills and an ability to translate technical information to non-technical teams, consider this career path, which has an estimated average annual salary of $103,800. There are now 6 major branches of engineering: mechanical, chemical, civil, electrical, management, and geotechnical, and literally hundreds of different subcategories of engineering under each branch. In the past, engineering could be divided into 4 major branches: mechanical, chemical, civil, and electrical, with sub-branches of each discipline. Today, however, the number of engineering degrees available have increased dramatically. There are now 6 major branches of engineering: mechanical, chemical, civil, electrical, management, and geotechnical, and literally hundreds of different subcategories of engineering under each branch. A mechanical engineering degree involves the design of mechanical systems. These systems assist industries such as manufacturing, aeronautics, nanotechnology, nuclear power production, heating and cooling. A primary focus is on thermodynamics, structural analysis, materials science, and kinematics. This is arguably the broadest of all engineering degrees available today and takes in a wide range of engineering disciplines. The mechanical engineering degree has a number of subsets that intermix with electronics and electrical engineering, such as mechatronics. An aerospace engineering degree involves the study of air and space travel. This might include military aircraft design and development, along with commercial airline design and satellite technology. The terms aerospace and aeronautical are both often used interchangeably, yet there are key differences between the two. Aeronautical engineering relates to craft that remain in our atmosphere, while aerospace engineering refers to aircraft that venture outside our atmosphere. Most programs in the United States have changed their names from aeronautical to aerospace over the past couple decades, but there are still some programs that go by the historical name. Biomedical engineering combines the study of medicine and biology. Biomedical engineers apply their design skills to biological and medical sciences. They do this to assist in advancements in healthcare treatment technology. They develop and maintain diagnostic devices. Devices that include EEGs, MRIs, and other imaging machines. Physicians use these machines to diagnose their patients' medical problems. This is a fast-moving industry and while challenging can be a rewarding career path to take. Automotive engineering involves the design and production of vehicles. The automotive industry is hugely diverse and requires engineers to work in areas such as mechanical design, performance, manufacturing, electrical engineering and systems management. Civil engineering involves the development of infrastructure such as buildings, railways, roads construction, bridges and general construction project management. Civil engineers also play an important role in rebuilding projects, such as in the event of a natural disaster. Civil engineers may work in the private or public sector at any level. This is a very broad engineering degree. Environmental engineering, structural engineering and marine engineering are all specialties of civil engineering. There are now 6 major branches of engineering: mechanical, chemical, civil, electrical, management, and geotechnical, and literally hundreds of different subcategories of engineering under each branch. In the past, engineering could be divided into 4 major branches: mechanical, chemical, civil, and electrical, with sub-branches of each discipline. Today, however, the number of engineering degrees available have increased dramatically. There are now 6 major branches of engineering: mechanical, chemical, civil, electrical, management, and geotechnical, and literally hundreds of different subcategories of engineering under each branch. A mechanical engineering degree involves the design of mechanical systems. These systems assist industries such as manufacturing, aeronautics, nanotechnology, nuclear power production, heating and cooling. A primary focus is on thermodynamics, structural analysis, materials science, and kinematics. This is arguably the broadest of all engineering degrees available today and takes in a wide range of engineering disciplines. The mechanical engineering degree has a number of subsets that intermix with electronics and electrical engineering, such as mechatronics. An aerospace engineering degree involves the study of air and space travel. This might include military aircraft design and development, along with commercial airline design and satellite technology. The terms aerospace and aeronautical are both often used interchangeably, yet there are key differences between the two. Aeronautical engineering relates to craft that remain in our atmosphere, while aerospace engineering refers to aircraft that venture outside our atmosphere. Most programs in the United States have changed their names from aeronautical to aerospace over the past couple decades, but there are still some programs that go by their historical name. Biomedical engineering combines the study of medicine and biology. Biomedical engineers apply their design skills to biological and medical sciences. They do this to assist in advancements in healthcare treatment technology. They develop and maintain diagnostic devices. Devices that include EEGs, MRIs, and other imaging machines. Physicians use these machines to diagnose their patients' medical problems. This is a fast-moving industry, and while challenging, can be a rewarding career path to take. Automotive engineering involves the design and production of vehicles. The automotive industry is hugely diverse and requires engineers to work in areas such as mechanical design, performance, manufacturing, electrical engineering, and systems management. Civil engineering involves the development of infrastructure such as buildings, railways, roads construction, bridges, and general construction project management. Civil engineers also play an important role in rebuilding projects, such as in the event of a natural disaster. Civil engineers may work in the private or public sector at any level. This is a very broad engineering degree. Environmental engineering, structural engineering, and marine engineering are all specialties of civil engineering. In the contemporary era, engineering is generally considered to consist of the major primary branches of chemical engineering, civil engineering, electrical engineering, and mechanical engineering. There are numerous other engineering subdisciplines and interdisciplinary subjects that may or may not be part of these major engineering branches. There are various different roles within each sector, and the list above only really scrapes the surface of what's available. However, hopefully after reading through the different types of engineering jobs, you'll have a better idea of the specific engineering career. This is by no means a complete list. In fact, most schools will have only the traditional disciplines available as majors. However, within these disciplines, you will most likely be involved in research or coursework that encompass several others. You may also notice that there is a great deal of overlap among disciplines. Engineering undergraduate programs often focus on theory, while technology programs usually focus on application. Graduates from engineering programs are called engineers, while graduates of technology programs are often called technologists. Engineers apply scientific, theoretic, and economic knowledge to research, invent, design, and build structures, devices, and systems, making for a broad discipline that encompasses specialized fields of engineering. Engineering technologists develop, design, and implement engineering and technology. Engineers often make a higher salary than technicians due to their higher level of education. Engineers are the team managers or leaders and oversee the work of technicians and other members of the team. Please make note of this homework activity. You must post the response in the discussion forum as it appears in Blackboard by creating a new thread under the activity. Using the internet, find the appropriate organization in Botswana for the following list of engineering disciplines. Depending on your personal interests, prepare a brief 2-page report about the goals and missions of the organization you have selected. Please make note of this homework activity. If you are studying electrical engineering, investigate how electricity is generated and distributed in Botswana. If you are studying computer engineering, investigate the uses of embedded systems in automobile. Post your responses in the Blackboard discussion forum. As a current engineering student, here are ways to put yourself on the fast track to success. 1. Identify the people who inspire you, and find out what makes them tick. If you love Apple products, Steve Jobs may be your idol, Or perhaps you love the Segway and its creator, Dean Kamen. You can easily find out a lot of information about jobs in Kamen, or just about any other prominent person in technology, so use it to look into what's helped these people and their companies become so successful. Then emulate their good traits in your personal, scholastic, and professional life. 2. Develop a portfolio of projects. Participate in every hands-on, experiential learning opportunity that a balanced schedule allows. This way, you'll have something unique to show a prospective employer, or venture capitalist, when you graduate, while other students will only be able to list their courses. In addition, you'll be far more likely to retain the knowledge you've gained in classes because you'll be applying it and, in the process, boosting your communication and interpersonal skills. 3. Learn the value of networking. When it comes to being a leader, whom you know is almost as important as what you know. Attend lectures on your campus and introduce yourself to the speakers. Check with your school's alumni association to get a list of alumni from your program who want to connect with undergraduates. 4-star tip. In addition to email, you can use LinkedIn or other social media tools to connect online. But remember, there's no substitute for a traditional, face-to-face meeting. So if you can find a way to meet in person, that's always the best. Pre-work discussion activity. Please post your responses in the discussion forum as and when it appears. There are 2 issues that are presented here. Issue 1. Botswana is currently facing 2 major environmental problems, drought and desertification. The desertification problems predominantly stem from the severe times of drought in the country. Due to the drought, 75% of the country's human and animal populations are dependent on groundwater. Groundwater use has eased the effects of drought, but has left a toll on the land. Groundwater is retrieved through drilling deep boreholes, which leads to the erosion of the land. Surface water is very scarce in Botswana and less than 5% of the agriculture in the country is sustainable by rainfall. Due to this, 95% of the country raises cattle and livestock as a means for an income. Therefore, it is not a surprise to see that 71% of the country's land is used for communal grazing, which has been a major cause for the desertification of the country. Source: African Books Collective, Environmental Issues in Botswana. Issue 2. Air pollution in Botswana. Vehicle emissions pose a serious threat to human health and well-being, especially in urban and peri-urban areas where the human population is too concentrated. Here are significant social and economic benefits to be gained by curtailing the health impacts resulting from intense exposure to emissions. Source: Department of Energy and the United Nations Environment Programme, UNEP. For both these issues, discuss in detail the effects and plausible solutions. Solution for Issue 1 and Issue 2 are presented. The effects of drought and desertification are: 1. Losing its bodies of water as well as vegetation and wildlife. 2. Desertification reduces the ability of land to support life, affecting wild species, domestic animals, agricultural crops and people. Issue 2 has long-term health effects from air pollution include heart disease, lung cancer, and respiratory diseases such as emphysema. Air pollution can also cause long-term damage to people's nerves, brain, kidneys, liver, and other organs. Some scientists suspect air pollutants cause birth defects. The next slide presents the plausible solutions. Your solutions might be different from what is presented here. Some of the plausible solutions to avoid the effects of drought and desertification are: 1. Generate your own electricity using small-scale wind turbines. 2. Harness the power of the sun to generate electricity and heat your water. Solutions to avoid the effects of air pollution are: 1. Machine learning and predictive analytics, to assess air pollution and quality. This method is helping to find pollution prevention solutions that will hopefully create a more eco-friendly environment. 2. Sustainable power generation for air purifiers. With this we come to end of this session. Please make sure that you complete all the activities posted in the discussion forum in Blackboard. I also would urge you to start working on the internal assignment 1, which is available under Assessment Resources in Blackboard. All the very best. Thanks for listening. Bye for now.